Number 30, a block of mass M is equal to 5.8 kilogram is pulled up theta is equal to 25 degrees incline as in figure P4.30 with a force of magnitude F is equal to 32 Newton. A, find the acceleration of the block if the incline is frictionless. Okay, maybe let's do the problem A first because we need to find it first, right? So here we will have this plane here with theta here is equal to 25 degrees. So this one will be 25 degrees. And then let's draw all the forces that work on this block here. And I will use this coordinate. The one that is parallel to the plane is the x-axis, and which one is the perpendicular to the plane is the y-axis. Okay, so my coordinates looks like this. And here we will obviously have the weight of the block, right? So we will have Fw here, and this angle here is also theta, right? And consequently, we can have this one here in the y-axis is the projection of this Fw, which is this one will be the adjacent and hypotenuse. So I will have Fw cosine of theta, right? And also we have the force that work from the plane into the block, and I will call that a normal force. So we have Fn like this, and then we will have this force here. We will have that F that, right? So from that one, and that F is 32 Newton. So we'll have 32 Newton here. And also we will have this one here, which is the weight of the block, but sine of theta. Fw sine of theta. Now, if the plane is frictionless, right? So we will have A here. The incline is frictionless. Okay, that means that we don't have any friction that works in the plane here. So there is no force of friction. So we will have only these forces here. So in the positive direction, I will have F, and on the negative direction, I will have Fw sine of theta. Remember the Newton's second law, sigma F is equal to the mass times acceleration. And here we work on the x direction. Okay, in the positive direction, I will have this F. And in the negative direction, I will have Fw sine of theta. Good. And we are looking for the acceleration. So we'll have this max. Good. Okay, now let's isolate ax there. And we will have F here. And then minus Fw. But Fw is mass times gravity. Right? And we will have sine of theta. And divide that by the mass. Good. And we know all the values, right? So we will have ax here is equal to the F, which is 32, minus the mass of the block, which is 5.8, multiplied by g, which is 9.8, and then sine of theta. Theta is 25 degrees. So I have 25 degrees. And then we will have the mass here. What is the mass? 5.8. Okay, and we can just plug all of them into calculator. So we will have 32 minus 5.8 multiplied by 9.8 sine of 25 degrees divided by 5.8. And I will have 1.38. Okay, so I'll have ax is 1.38 meter over squared seconds. And that is the answer for question A. So we'll have ax here is equal to 1.38 meter over square second. Good. And now let's move on. Find the acceleration of the block if the coefficient of kinetic friction between the block and the incline is 0.10. Okay, let's clean this up here. Okay, we are given that mu k is 0.10. We'll have mu k is equal to 0.10. Okay, because we have the friction here, we have one more forces, right? So here we will have the force by the friction. Okay, let's name that as force by the friction. Okay, but then force of the friction here is mu k times the normal force. Okay, we have another problem here. We don't know the normal force yet, right? So we'll have Fn here. So we need to do analysis on the y direction first. Good. So we will have sigma F in the y direction here is equal to the mass times acceleration in the y direction. However, the block is only moving in the horizontal direction. It's not flying or it's not falling, right? So we will have this one here on the right-hand side is equal to 0. Good. And on the positive direction, I will have the normal force. So we'll have Fn. And then minus this one here is Fw cosine of theta. Fw cosine of theta. And all of that will equal to 0. And we can isolate for Fn here. And Fw is just mg. And then multiplied by cosine of theta. We know all the values, right? So the mass is 5.8. G is 9.8. And then cosine of theta. Theta is 25 degrees. Okay, so we will have the normal force here. That will be 5.8 times 9.8 and then cosine of 25. Okay, and I will have 51.51. 51.51 and the unit here will be in Newton. Okay, maybe let's save this and clean this up because I need some space here. Now what we need to do is to do analysis but on the x direction. So we already have that. So sigma fx is equal to the mass times acceleration here also in the x direction. And then on the positive direction, I will have this f here. And then minus, I will have Fw sine theta. I will just write it mg sine of theta, right? And then we will have also the force of the friction in the negative direction. And that will be mu k times Fn. So I have mu k times Fn. And that will be mass times Ax. Okay, we need to calculate Ax. So let's just isolate Ax. So I'll have that. This one will be our numerator, mg sine theta minus mu k times Fn, and divide that by the mass. Okay, so we will have Ax here. Okay, what is F? F is 32 Newton. Okay, minus mass, so we'll have 5.8. And then G, we'll have 9.8. And then sine of theta, so we'll have sine of 25 degrees. Then minus 0.10 multiplied by Fn. Fn is 51.51. Good. Divide all that by the mass. So we will have 5.8. And we can have this one here, Ax. Okay, let's just plug that into calculator. 32 minus 5.8 times 9.8 and then sine 25 degrees minus 0.10 multiplied by 51.51, divide that by 5.8. Okay, and I will have 0.49. Okay, 0.49. And the unit will be meter over square seconds. And that is the final answer for this problem. Hopefully I did not make any mistakes during the calculation. So the AX for question A is this one, and for question B is this one. Thank you for watching and see you in the next video. Bye bye.